Hello, and welcome to MidiAmigo. MidiAmigo is an Android app for musicians, working with MIDI streams. There's an introductory video that can be found also on this YouTube channel. MidiAmigo is built around the concept of modules. The app has numerous types of modules built in, for all kinds of MIDI processing. In this video we focus particularly on one module type, the message converter module. Note that the MidiAmigo app is still in development. It is not available yet in the Google Play Store. What you're about to see is a preview of its capabilities right now, in the development version. We hope to publish the app in the near future. Let's begin with creating 3 modules on the canvas: a MIDI in module, a message converter module, and a MIDI out module. We connect them together to form a simple chain, so MIDI messages can flow through them later on. Before we continue with the configuration of this setup, let's first explain 2 ways of how you can use this setup with MIDI instruments in practice. Scenario 1. You connect MidiAmigo with 2 different instruments in the MIDI in and MIDI out modules, so the message converter module converts the MIDI messages in transit from one instrument to the other. For USB devices, this requires a USB hub, since the Android phone running MidiAmigo must communicate with 2 instruments, while it only has one USB port. Scenario 2. You connect MidiAmigo with a single instrument, so you select the same instrument in the MIDI in and MIDI out modules. This is typically done with keyboards that generate their own sound, like a synthesizer or a digital piano, not a MIDI controller. For USB, this can be done with a single USB connection. In this second scenario, MidiAmigo sits in between the keyboard part and the sound generator part of the MIDI instrument. So the message converter module intercepts the MIDI messages coming from the keyboard part, converts them, and then sends the converted messages back to the sound generator part of the same MIDI instrument. For this to work, the MIDI instrument must be told that it should not listen to its own keyboard part to generate sound. It should only listen to the external MIDI messages, in this case coming from an Android phone running MidiAmigo. The setting in the MIDI instrument to ignore the local keyboard part is called local off. If local off is not applied, the sound generator will be triggered twice, often leading to an unwanted phasing effect. Okay, now back to our own setup. This phone is connected to a Korg Kronos workstation via a USB cable. So let's select the Kronos in the MIDI in and MIDI out modules. You can set the Kronos also as default in the global settings, so you would not have to do this in the future. But for now, just simply select. We're currently in design state. For MIDI messages to be processed, we must switch to run state. This is done by pressing the play button in the toolbar, so it turns yellow. If we now play the Kronos, we hear the notes playing, and the modules and connections light up yellow, as a sign that the messages are actually processed. However, the message converter module has no conversions configured yet, so it simply forwards all MIDI messages it receives, unaltered, to its successor module. Moreover, we can hear a slight phasing effect. This is because the Kronos has not been set to local off yet. This results in double triggering of all notes played, which you can clearly hear as a phasing effect. We don't want this, especially not since we want to convert the original messages. So let's set local off in the Kronos's global MIDI settings. Okay, You now hear that the phasing effect is gone. Every MIDI message is received only once by the Chronos, coming from MidiAmigo, which is exactly what we want. We can now focus on adding conversions. Let's double-click on the message converter module so it opens up in the module screen. The Conversions tab is already selected. At the bottom of the screen, above the module tabs, you can see two buttons, Add and Quick Add. Both of these buttons create new conversions in the module. With Add, we can create and configure a single conversion manually, filling in all the details ourselves. With Quick Add, a wizard opens up, via which multiple conversions can be added via MIDI Learn, also called Get from MIDI. For many conversions, this is the quickest way, but it is still important to understand what happens behind the scenes, if you want to tweak the conversions afterwards. So we will first use the manual approach, to familiarize ourselves with the process and the UI. We press Add, and a dialog opens up. The dialog shows the configuration of one conversion. We can give it a name. Let's do that later. We can select a type. There are 3 types of conversion to choose from. The default type is on MIDI message. This means that each incoming MIDI message will be converted into 0, 1, or more outgoing messages. This is the most common type of conversion. The other 2 types are not really conversions per se, but are still important in the process. On start means that you can configure a series of outgoing messages to be sent whenever this module goes from design to run state. For instance, to set some MIDI controller to its default state. And on stop sends MIDI messages when going from run state back to design state. For now, let's focus on MIDI message. There's a setting called fall through, which we will not cover at the moment. We will focus on the following 2 sections: the incoming message, and the outgoing messages. The incoming message is really a filter configuration. You can precisely select which MIDI messages trigger this particular conversion, and therefore also, which MIDI messages are ignored. As you can see, by default, any MIDI message triggers this conversion. Let's narrow this down, by pressing incoming message. This opens up another dialog. We can select the receive port for the incoming message. Let's leave that to its default value right now. The most important setting is the message itself. If we click on its value, which currently is any, another dialog pops up, via which we can specify exactly which message, or messages, will trigger this conversion. Let's first invert the selection, so we go from any to none. Everything turns white, which means that at the moment, no MIDI message will trigger this conversion. Only blue message types will trigger. We will soon select some specific message types. First, let's have a look at how this dialog works. We see that we can select from a list of 4 groups of messages: channel messages, system messages, meta messages, and internal messages. These groups have been briefly explained in the introductory video. We can select messages as a whole group, or click the plus to open up groups, and select individual message types. For the first conversion, let's select Note On and Note Off, and click OK. When we return to the previous dialog, we see that the message filter now contains the 2 selected message types, and that the contents of the list now also contains all message properties that are common for Note On and Note Off. These additional properties are channel, which is the MIDI channel; key, which is the actual key pressed or released; note, which is derived from key; and finally, velocity. Note that this dialog will always show all common properties of the message types that are selected, which is very convenient. We see that the incoming message filter now contains constant values. So, only a note C4 on MIDI channel 1, with a note on velocity of exactly 100, will trigger this conversion. That is not realistic. Let's change this now. When we click on Channel, a dialog opens up, via which we can select a single MIDI channel. However, sometimes we need a conversion to be triggered via multiple channels. The message converter module can do this as well. Close the dialog, and click on the three vertical dots to the right, in the channel row. Instead of a single constant value, select Value Set. If we now click on Channel, we can select more than one channel. We can even select all 16 MIDI channels if we want. Or another example, is to select all channels except for one, to filter it out. For now, we select channel 1 and 2, and press OK. Now we will change which notes, or rather, which key range, will trigger this conversion. If we click on the current key value, which is 60, or C4, we can pick exactly one other key. This is not what we want. Let's change the input from constant value to value range. Now we can select a key range. Let's select notes from C5 and higher. We can do this via a slider. We can also select it separately if we want. Press OK. Finally, let's put a range on the velocity. Select the three vertical dots again, and choose Value Range. In this case, we will use the Get from MIDI feature of MidiAmigo, also known as MIDI Learn. Click on the MIDI DIN button, next to the bottom value. The app will be brought to run state first, so we can receive MIDI messages from the Chronos. We see a yellow border. Now we press a key with medium velocity on the Chronos. The bottom velocity value is detected. We do the same with the top velocity. We press a key on the Chronos keybed firmly. This is our top velocity. Press OK. We've now completely configured the incoming MIDI message filter for this conversion. We mostly entered all values manually. There are quicker ways to do this. We can use the Get from MIDI feature also on the message as a whole, rather than on individual message properties. We'll see that later on. Now we press OK again, to return to the first dialog. You can see a summary of the incoming message filter settings. We will now continue with the configuration of the outgoing message. Note that if we would leave the list of outgoing messages empty, that would mean that this conversion really is a message filter. All messages will be forwarded, except for the messages that match the incoming message configuration. This can be handy, but in our case, we want an actual conversion, not a filter. So we press the Add button, at the bottom of the dialog, to add an outgoing message. By default, it says, Keep, which means that the outgoing message is identical to the incoming message. Sometimes we might want to keep the incoming message as one of the outgoing messages, but in this case we don't want that. So let's change this configuration. A dialog opens up, via which we can change all outgoing message properties, exactly the way we want them to be. First, there is Send port. We leave it at default, but you could choose any port available in this module. We can even select an input port, to send the outgoing message to ourselves, instead of sending it to the next module in the chain. But as said, in this case we will send it to the default output port. By the way, in the message property dialog, you can also click on the blue property name. It will show a brief help text on what the property is about. Next up is Send Delay. By default, it is 0 milliseconds, but you can send this outgoing MIDI message also in the future, up to a minute's delay, after the incoming message triggered this conversion. You could use this for instance to generate short arpeggios, setting different delays for each outgoing note. But in our case, we leave it at 0 milliseconds, and send the message immediately. The next property of the outgoing message is the message type. By default, it says, Keep, so it is the same as the incoming message. So in our case, a note on will stay a note on, and a note off will stay a note off. But we could change that into any other message type. We'll do that later, in another example. The next property is the MIDI channel. Again, we will keep it the same as the incoming MIDI channel in this example. So it will be either channel 1 or channel 2, as specified earlier on. But it is clear that you can set the outgoing channel to any of the 16 MIDI channels. Next property is the key, which is the pitch of the note that is pressed on the Kronos. Let's transpose the original key, 1 octave up. Click on the 3 vertical dots, and choose expression. If we now click on the value, we can enter an expression, which is basically a formula that can contain property values from the incoming message. The incoming message is represented here by the letter M. If we want to take the incoming key and transpose that 1 octave up, we will enter M dot key plus 12 and press OK. You can enter more complex expressions or use different property values from the incoming message, but in this case, a simple addition of 12 to the original key is all we need. The last property we can change is the velocity. Let's enter a fixed velocity of 120. So we change the input to constant value and enter 120. Then, press OK to return to the first dialog. You can see a summary of the first outgoing message, with the expression in double accolades. Values that are kept the same as in the incoming message are not shown in this summary, except for the message type. We could add more outgoing messages if we wanted, but for this example, let's leave it to 1. So, to summarize, all incoming notes on MIDI channels 1 and 2, which are equal to, are higher than C5, and have a note on velocity, which is in the given velocity range, will be converted to the same message, but an octave up, and with a fixed velocity of 120. To be complete, MidiAmigo will take care that velocity ranges are handled correctly. This means that in the incoming message, only note on velocities will be compared with the configured velocity range. The note off velocities will not be compared if note on messages are also part of the configuration. The note off messages will trigger the conversion when its note on counterpart had also triggered the conversion for the same key and MIDI channel. MidiAmigo keeps track of this automatically. Perhaps this all sounds quite complicated, but simply know that velocity ranges just work. Looking back at all the values we've entered in the UI, it may seem that it is a lot of work just for one conversion, but remember that with MidiAmigo, you can literally convert any MIDI message in any series of converted MIDI messages, and also use complex expressions and value ranges, even with more complex MIDI messages, like system-exclusive messages. We tried to implement a UI that is extremely flexible to cover all possible scenarios, but still is intuitive enough to understand for users that are familiar with the MIDI protocol. And also remember that things get simplified when using the Quick Add Wizard, which we'll demonstrate later on in this video. The only thing we still have to do is to give this conversion a descriptive name. Let's call it octave up fixed velocity. And then finally press OK. We're coming back to the module screen, and since we changed the conversion configuration, MidiAmigo also went back to design state automatically. To try out this conversion, let's click Run, so the play button turns yellow. We use MIDI channel 1 on the Kronos. As we can see and hear, notes lower than C5 are unchanged, and notes with velocities that are not in the specified range are also unchanged. In other cases, our conversion gets triggered, and the note is transposed an octave up, with a fixed velocity. You can also see that in the UI, the checkbox of the conversion lights up yellow, whenever this particular conversion gets triggered and executed. We can also uncheck or disable this conversion at runtime, which can be very convenient. Simply turn individual conversions on and off, at will. Of course, highlighting, disabling, and enabling conversions at runtime in the UI costs a little performance overhead, especially with many MIDI messages flowing through this module in a short period of time. Therefore, you can disable these runtime features if you want. However, the performance overhead is minimal in our case, so we'll leave them on. Now, let's talk about how the flexibility of the MidiAmigo message converter module is actually implemented. In the introductory video of MidiAmigo, we showed that the app has a built-in scripting language, called Amigo Script. It is loosely based on JavaScript, but it's got special features to process and manipulate MIDI messages. In MidiAmigo, there's a script module, via which you can program scripts yourself. So you can write your own, tailored, conversions yourself, if you know a bit of programming, and are familiar with the MIDI protocol. The message converter module is there for people that do not know or do not want to program all conversion details themselves. This module is basically a very flexible UI that generates the script for you. Whenever you made changes to the conversions, before the app is brought into run state, the script code is regenerated and recompiled. The script will do all the message conversions at runtime. It seems perhaps that a script executes less quick than low-level program code. But remember that Amigo Script is a compiled language, and it's optimized for execution speed in various ways. For almost any real-world MIDI use case, it absolutely runs speedy enough. Feel free to test it yourself with our free version when it becomes available. Let's return to our example. You can view the generated script using the accolades or curly braces button in the top right corner below the main toolbar. If you know JavaScript programming, the code should be quite readable for you. It also contains quite a few comments, bringing additional clarity. Now, let's add another conversion. Since we've covered the UI a bit, we can do it now more quickly. Let's simply convert a channel aftertouch message into a filter cutoff, control change message. So when we press firmly on a key on the Chronos and activate aftertouch, the filter should open up. In the incoming message, for the message type, select a constant value of aftertouch. We'll leave the MIDI channel at 1. And for the incoming pressure, we set it to a value range of 80 and above. For outgoing messages, let's keep the incoming message as one of the outgoing messages. So the aftertouch message will be forwarded unaltered. Then, add a second outgoing message. In this case, we duplicate it from the first, via the options menu, just to show that it's there. Open the second outgoing message. Now, instead of entering values manually, click on the MIDI DIN button. It opens up a dialog which will MIDI learn the outgoing message. On the Chronos, twist the knob that generates CC number 74, which is the filter cutoff frequency. MidiAmigo recognized the received CC, including the MIDI channel it's received on. Press OK. As you can see, all message property values were set by MidiAmigo automatically. Even the expression for CC value already refers to the aftertouch pressure value of the incoming message. Click OK. Give a descriptive name to the conversion. Aftertouch to cutoff. Click OK and store the new conversion. For clarity, Let's disable the first conversion for a moment, because conversions are evaluated in this order, and the first one that triggers will be the only conversion executed. Bring the app in run state now. On the Chronos, when we press a key firmly to activate Aftertouch, we hear the cutoff value kick in. However, the filter opens up rather abruptly. This is caused by the fact that we have a value range on the aftertouch pressure, of value 80, and above, while the default value is usually 64. So once the conversion is triggered, the cutoff jumps to the value of 80 immediately. We can prevent that by altering the expression formula in the outgoing message. Let's transpose and rescale the aftertouch pressure to the cutoff range that is left. Let's try it out on the Chronos, in run state. You hear that there is no jump in the cutoff frequency anymore, we have a smooth opening of the filter. As you can see, the fact that MidiAmigo uses a full-fledged scripting language under the hood, makes it possible to use any expression formula, supported by the language. Okay, let's add another conversion, this time, using the Quick Add wizard. Press the button at the bottom of the screen. The wizard begins with an opening message, an invitation to use the keyboard controls, in our case, on the Chronos. We want to convert the messages from the first fader on the Chronos, to a mod wheel change. The fader is implemented as a system-exclusive message in the Chronos. The mod wheel is a control change message, CC number 1, generated by pushing the Chronos joystick forward. So in this example, we convert from system exclusive, or sysx, to CC, using the Quick Add wizard. Press Next. Now simply move the first fader on the Chronos. The wizard detects sysx. Press Next again. You now have a choice of keeping the original incoming fader message as part of the outgoing messages, or not. Those are the first two options. The third option is to send no outgoing message at all, and thus filter the fader away. For our example, we choose the second option. We want to replace the fader with the mod wheel. Press Next. The wizard is now ready to detect the first outgoing message. On the Chronos, push the joystick forward, and let it return to middle position to generate the mod wheel messages. As you can see, the wizard detects it as CC number 1. Press Next. We only have one outgoing message in our example. So we choose the second option here, and press Next. The wizard now generates a suitable descriptive name for the conversion. You still can edit this name, but it has to be unique among all conversions in this module. Press Next. The wizard asks if we want to add another conversion. For now, we say no, and press Next. And then OK, to finish the wizard. Open the conversion now, and see what it looks like. In the incoming message, you see a system-exclusive message. Let's have a look at the data. During movement of the fader, the wizard detected that only the last byte before the F7 was changed. It stores it as a variable, v1. This variable v1 can later be used in expression formulas in the outgoing message. Let's see if this is the case. Open up the outgoing message. We see the control change message CC number 1 there, the mod wheel, on MIDI channel 1. And indeed, in the CC value property at the bottom, we see an expression that uses variable v1. So the sysx fader value is successfully transferred to the mod wheel value, all automatically configured by the Quick Add wizard. Let's now go to run state, to see and hear if it actually works. Yes indeed. When we move the first fader on the Chronos, we hear the same effect as if we would push the joystick forward. We hear the mod wheel effect. This is what the Quick Add Wizard is all about. Swiftly adding conversions with minimal UI interaction. The wizard has some more features, but those fall outside the scope of this preview. Now, as a next example, let's do it the other way around. We create a conversion that takes a mod wheel change as incoming message, and a sys-x fader as the outgoing message. We choose an organ patch on the Chronos, so we can see the first drawbar move, on the Chronos touch screen, when we push the mod wheel forward. Let's use the Quick Add Wizard again, to configure this conversion. Since we already explained its UI, we can now advance a bit quicker. This time, for our incoming message, we push the Chronos joystick forward, to generate the mod wheel CC number 1. As the only outgoing message, we move the fader, representing the first drawbar of the organ. Finally, check the generated name, and finish the wizard. Let's bring the app in run state again, and see if it works. We push the joystick forward, and back to middle position, on the Chronos. As we can see on the Chronos touch screen, the drawbar moves, but not the way we want. It moves too quickly, and in reverse direction. This is due to the fact that the Chronos only uses the first 10 values for the drawbar position, whereas the mod wheel, or joystick, generates the full range, from value 0 to 127. This is easily fixed, by changing the expression formula in the outgoing message of our conversion. So open it up, and inspect the sys-x data property. We see that in the last byte before the F7, an expression is configured by the wizard, which uses the full mod wheel CC value range. If we divide the CC value by 12, we should get closer to where we want to be. Let's try this out. Yes, it works, but the drawbar still is reversed. Let's fix that too. Great. This is indeed what we want. Let's have a quick peek of the script code it has generated. Okay. Looking back, we've covered a lot. Manual configuration, script code, get from MIDI, or MIDI learn, and finally the Quick Add Wizard. But the message converter module even has a few more tricks up its sleeve. Especially in cooperation with other modules in MidiAmigo. We will not cover these examples in detail in this video, but we'll give a quick peek into what's possible already. First of all, because the message converter module is basically a UI, on top of a code generator, we've also included options to let the user write custom code, both for startup, and for insertion in specific conversions. These code snippets will be merged into the final script, during code generation, and before compilation. Of course, you can also copy the generated script code over to a separate script module, and edit and run it there. But then, the link with the UI will be broken. It works in one direction only, which is understandable. So if you want to interact with a UI, either via the manual approach, or via the wizard, it's better to keep it all inside the message converter module, for better maintainability. Another feature of the message converter module is that, like other MIDIAmigo modules, it can respond to internal, proprietary MIDI messages, to change its behavior at runtime, without UI interaction. This is called automation. For instance, it can toggle specific conversions on or off, based on automation messages. It can even cycle through a series of conversions that all have the same incoming message, but different outgoing messages. A typical example would be a foot switch that needs to respond differently every time it is pressed. Here you see an example where the foot switch is emulated by a script. At every foot switch press, the module applies the associated conversion, and then cycles to the next conversion automatically, to be ready for a next foot switch press, with a different response. At the end of the list, the cycle returns to the first conversion, to start over again. The possibilities with automation are endless. Note also that the message converter module can also work with MIDI messages coming from standard MIDI files, not only from live MIDI streams. This means that it also can convert meta messages, like tempo, lyrics, or SMPTE. This can all be realized with the message converter module. And remember that the message converter module is only one of the dozens of module types inside the MidiAmigo app. So, MidiAmigo is intended for musicians, or audio-video artists, who want a portable solution for their MIDI challenges, and do not want to use a laptop, or dedicated hardware. When the free version of MidiAmigo becomes available, give it a try, and see for yourself if this Android app ticks all the boxes. Thank you very much for taking the time to view this video till the very end. Feel free to like, comment, share or subscribe. Have a nice day, and be sure to make some music. Goodbye.